grab one if you will. And following the second panel of this morning, so the theme will be technologies for green hydrogen production. So our audience can participate through in written, sending questions with our QR code and our WhatsApp number. And this is our WhatsApp number and the QR code for those who are following. And you can do you can participate with the Q&A. So let's get to know our next lecturers. Well,
now to comprise our panel,
Para o nosso painel, eu queria convidar a vir aqui ao palco o senhor Luiz Melo, gerente de desenvolvimento de negócios da ThyssenKrupp.
Mr. Daniel Lopes,
Senhor
Director,
Daniel Lopes, diretor da Hitron Energia e Gases Especiais.
Ms. Marina Piva,
A senhora Marina Piva, engenheira de aplicação
Green,
da unidade
New
de
Energy
soluções de
Business
hidrogênio verde, New Energy
from
Business,
Siemens
da
Energy,
Siemens Energy,
remotely,
participação de maneira remota.
and
Assim
Mr.
como o
Kamakan,
senhor
Business
Kamakan,
Development Manager of Pin
Business
Power
Development
Hydrogen
Manager
Group
de
Limited,
Power
or
Hydrogen Group
CDH2,
Limited, o
will also be
CDH2,
here
também
remotely.
participará de forma
To
remota.
moderate this panel,
Para a
I would
moderação
like to
deste
invite
painel, convido a
Monica
senhora
Saraiva, a
Mônica
consultant
Saraiva,
for
consultora da Federação das
the
Indústrias do Estado do Ceará, por gentileza.
Federation of Industries of the State of Ceará, and we inform to each of the lecturers that they will have 15 minutes to
E solicitamos então que se mantenham dentro do nosso horário de programação.
They will have 15 minutes for their speeches, and when we are a few minutes away from the deadline, I will give each of you a warning.
5 minutos para a sua apresentação inicial.
I would like to thank all of you and say hello to everyone that is here, Marina Piva, Daniel Lopes, those who are online with us. I remember last year, I believe in March, two international companies, global companies, leaders in electrolyzing technology. The electrolyzer is today the fad. It is the most required equipment, one that produces green hydrogen and electrolyzes the water. They'll explain better. And I was very happy because in March in 2021, these companies announced that they are offering these technologies in Brazil, meaning the full plant, from the project, the engineering project, installation, implementation, and maintenance. This was a very important issue for the Brazilian market because clients, those that are interested in installing and producing green hydrogen, they didn't have to request a proposal in Germany, United States, or any other country. Now they had it available here, and it took months to arrive here. And when it did, because sometimes they had too many requests to answer those from the local market. A company that didn't have a developed market yet.
Então, o fato dessas empresas, a ThyssenKrupp já está no Brasil há quantos anos? Mais de 100 anos.
Siemens has been here, I believe, a little less than 100 years present in Brazil. So this was a milestone in our Brazilian market, without any doubt. And hydrogen has a sensational story, one that Daniel is going to tell us. It's a Brazilian company with Brazilian origins that was a Unicamp spin-off, and it survived all Brazilian crises. crises
sobreviveu a todas as
and market
ondulações do
waves
mercado, sobreviveu, inclusive
and
assim,
survived
com louvor.
spectacularly. It
Não
not
só
only
sobreviveu,
survived, but it
como teve
thrived,
sucesso
and
nesse
it was
processo.
successful.
E o ano
And last year, it
passado
became a
se
global
tornou uma
company
empresa global,
and was
foi
acquired by a
comprada por uma
German
empresa
company,
alemã chamada Neumann Nessa, grupo
a German group that
que inclusive oferece,
offers
produz
several
várias
technologies that are
tecnologias
complementary
complementares
to
à
Hydro's.
tecnologia da Hydro. E o mais importante é que a
And the
Hydro
most important fact is that
se
Hydron
manteve como centro de
maintained
competência de
itself
eletrolisadores no
as
Brasil.
a
Então,
very
são
competent
três
company here in
empresas
Brazil. So there
que
are,
realmente eu tenho
these are three
orgulho de
companies that I'm
trazer
very proud
aqui
to bring here, and I'm
e
proud to
tenho orgulho de
present.
apresentar,
And they have
porque eles
developed
têm
a fantastic
desenvolvido um trabalho fantástico
work
para
and
desenvolver esse
help advance
mercado
the market
do
of green
hidrogênio verde
hydrogen
no
in
Brasil.
Brazil.
Obrigada.
So now I'm going to
Eu vou
call,
chamar
first of all, Luiz.
primeiro
Luiz
é o
Melo,
Luiz, né?
please.
Luiz Melo, por favor.
It's a pleasure to be here. Thank you, everyone, for your presence. Thank you, Fiec, Monica, for your invitation. It's a fantastic event. Unfortunately, I wasn't able to be here yesterday, but the structure is incredible, and I'm very happy. Green hydrogen became a theme here in Brazil very quickly, a relevant theme for society, for industry, for government, and this is something that brings me great joy. I believe I'm going to begin this lecture saying that last week was a very special one for us. Many of you maybe have seen in the news the first contract signed by Group. It was the first green hydrogen, scaled green hydrogen project here in Brazil, first in the South Hemisphere, and we celebrated this intensely. Last week we didn't have enough time to do that, but it is a very challenging project in terms of deadlines, and we celebrated very quickly and ran back to go to work. And now we have this challenge of delivering this project together with Joe. Now I'm going to talk a little bit about the project itself. Let's get started here. It seems that at least every month, Mother Nature reminds us that we have to change things up. We have to change the way that we generate and use energy worldwide. This month, we have seen heat waves, intense heat waves, and wildfires in Europe that are clearly effects of global warming. So I believe what most motivates all of us here is waking up in the morning, working hard, and knowing that we are working towards a better world in the future. I believe that here in Ceará, we have a huge potential to be part of the solution. I'm showing here a Bloomberg study that says that until 2050, the cost of green hydrogen produced in Brazil tends to be the cheapest in the world. And I believe that the facts prove that. We have a renewable energy production capacity that is very competitive regionally in relation, for example, to Chile. For example, Chile can have some cases of producing energy that is cheaper than Brazil, but in terms of expansion and competitiveness in the energy generation capacity, we are much larger than Chile. It's clearly shown that green energy cannot just be renewable, it has to be new. It's no use to take energy from a plant that has been there for years to withdraw the energy from a normal grid and have that energy lack. And here in Ceará especially, we have the combination of being able to combine aeolic and solar energy, which is, once again, a great advantage when we talk about green hydrogen, and an industrial plant that ideally needs to be operating as much hours as possible per day in order to provide greater return or yield. What we believe is that the green hydrogen business is a viable business on a large scale. First of all, because the technology chain involved from the production of solar, or hydroelectric energy, electrolysis itself, the logistic chain of transport through ammonia and ammonia plants, the ammonia transport using vessels is viable on large scales. I'm not going to say that there won't be niches. There will. But even based on Sync Group's history, what we want is to be a leader in large-scale applications, industrial applications. That's what we believe in. Now, talking a little bit about our green hydrogen technology, production technology, I'm not going to. Green hydrogen is basically the electrolysis of water and using energy to break water molecules to get hydrogen and oxygen. So our greatest input is water and energy.
Alkaline water electrolysis, eletrólise alcalina da água, que basicamente você abastece com água o
It's
eletrolisador.
basically, you fill with water the electrolyzer and you have an alkaline solution based on potassium salts diluted, helping the electrons to be transmitted within the element. So the electrolysis, it just happens. We have a capacity of 20 megawatts of electrical energy consumption that will normally produce 4,000 of cubic meters of hydrogen per hour, kind of 9 tons of hydrogen per day. It is a technology that is very mature, and because ThyssenKrupp works with electrolysis technology since the 1950s. We've been working mainly with chloride alkaline solutions, and the caustics soda and chloride soda, and it's based in electrolysis, and our water electrolyzer, so the mechanical design is based on a tested and approved design with chloride soda design, so it heritage of the know-how of electrolysis from the 1950s. It is a non-pressurized equipment, a low pressure, so we have some equipment with a great longevity, typically with electrolyzers, and with we have 30 years of and we need to do a recoating of electrolysis cells to regain energetic efficiency. And as Monica said, so ThyssenKrupp is in Brazil. We are working for more than 100 years in Brazil, and we serve the chloro soda in Brazil. Carbochloro, Unipar Group, Braskem, using our electrolysis for chloride soda. We have an infrastructure in Brazil for technical service, and I think this year we'll have our equipment certified and with ISO specific normative for green hydrogen electrolyzers. And then some months ago, and we believe that we have the best solution possible and for big scales of green hydrogen.
Repassando aqui pouco das
Also,
características
just reviewing,
técnicas,
so the
né,
technical
do nosso
characteristics of
equipamento.
our equipment
Como eu
here.
disse, módulo,
As
né,
I've said,
consome
one
20
module
megawatts, ele
has a
traz
consumption
uma
of
capacidade de
20
produção de
megawatts.
4.000 normal metros cúbicos por hora.
And
Com
with
hidrogênio, o hidrogênio sai numa pressão
cubic
de
meters per
4.3
hour,
bar, né, que é uma pressão
4.5,
pouco acima da pressão do
4,000,
Fiec.
no, 4
Questão de operação, né?
cubic
Isso é
meters
muito
per hour of
importante, né? A
production of
capacidade que
hydrogen.
o equipamento
And
tem
the
de
capacity of
modular a sua
operation, so
capacidade em função da
the
disponibilidade de
capacity of energy
energia,
availability
que você
that
entrega para
you
ele.
deliver
Quando você
to the
trabalha com
equipment
energias
working with
renováveis, nem
renewable
sempre você
energies.
tem, né,
Not always you
uma
have
oferta,
the
né, de
proper
energia
energy
para o
offer
equipamento
for the
constante,
equipment.
contínuo, né? Então você
And
tem que
you
modular a
need to
capacidade
module the
em
capacity
função da energia que você tem
and
disponível.
regarding the
A gente
energy you
consegue
have
trabalhar
available.
com o nosso equipamento
And
entre 10% de capacidade a
you
100% de
have
capacidade
10% to
e o tempo, né,
100%
de
regulation of
resposta, de
capacity,
ramp-up,
and you
ramp-down,
have
entre
ramp
esse
up and ramp
intervalo
down
de
in this
capacidade
capacity
é bastante
interval that is
rápido, né?
very
Fica menor aí de 30
short time,
segundos.
less than 30 seconds.
Disponibilidade operacional, né, muito alta, né, como eu disse, já contando, né, com manutenções que
So
você tem que fazer a
counting
cada
on
7, 8
maintenance,
anos, de recoaching,
you
de
have
você ter
recoaching,
que realmente tirar as eletrocélulas
taking
para
off
fazer
the
esse recoaching.
electrocells for this
Mesmo assim,
recoaching,
você consegue uma média
even
de
though you have an
98%
average
operacional
of operation
de
of
98%,
98%.
né? Esse processo
This
também
process
que ocorre a
that
cada 8 anos
happens
também,
each 8
trabalhamos
years,
com sistema de leasing, né?
you
Então
have a
você tira uma
leasing system
eletrocélula
taking
para a gente fazer o
out an
recoaching,
electrocell
a
for
gente
the recoaching,
te dá uma
and you
eletrocélula,
have
você
an
repõe ao
electrocell
longo do tempo que a sua
for
máquina rodou, quer
reposition
dizer, é possível você também
and
manter
replacement.
sua
So it's
capacidade
possible
mesmo durante essas
to
manutenções.
maintain the capacity during
Falando de
maintenance.
eficiência, né? A gente costuma mostrar eficiência. Muita gente pergunta qual a eficiência do seu equipamento? 80%, mais de 80, menos de 80.
And normally,
E às vezes
so
esse número
this number
não é tão
is
claro, né?
not
80%
too much
de
clear,
base,
so
né, em
it's
relação a quê?
80%
A
as
gente
a
prefere
baseline.
dar
We
um número,
prefer to give
dar um
some
número aí de consumo de energia
numbers of energy
por
consumption per
metro cúbico produzido
cubic meter
de
produced,
hidrogênio, né?
hydrogen produced.
São basicamente dois
Basically,
números que eu
these are
mostro
two
aqui, né?
numbers,
O 4,5 kWh por
4.5
normal metro
kilowatt
cúbico
hour
é a
per
eficiência, vamos chamar
cubic
assim, quando você
nanometer.
entrega com a eletricidade já entregue no que a gente chama de
And
stack, que é o conjunto de células
you have
eletroquímicas,
a
né?
set
Quer
of
dizer, a energia
electrolytic
já
cells
passou
that we
por
call stack,
transformador, retificador,
and
e
it
ela está
passed through the
entregando ela aqui
rectifier.
no stack, você vai
Delivering
ter
it
essa
in the
eficiência
stack,
aqui
you'll have
de
this efficiency
consumir
of
4,5
4.5
kWh por
kWh
normal metro
per
cúbico de
cubic
hidrogênio produzido.
nanometer.
Mas
Nanometer.
número aí que eu acho que é o
And
mais
but the number that is more
consistente
consistent
quando
when
você vai
you
fazer uma primeira conta, né, de
do the
viabilidade
first math of
de um projeto de
feasibility of
hidrogênio
this
verde,
green hydrogen project.
a minha
So
tradutora de línguas está um pouco
my
na frente ali, mas é
the sign
4,9
language translator
kWh
is,
por normal metro cúbico.
you know, it's
Esse número,
front
que é um
of the
pouco
image is
maior, tem um consumo de energia um pouco
4.9
maior, o que ele
kilowatt
leva em
hour
conta,
per
né? Ele leva em
cubic
conta que
nanometer. And this
uma
number
planta
takes
de
into
hidrogênio
account that a
completa é como
complete
caixa preta, né? Então,
hydrogen plant
você
is a black
entregando
box
uma energia aqui em
delivering an
corrente
energy,
alternada, você vai ter,
and with
lógico, perdas
alternated
nos
current, you'll
transformadores, nos
have obviously
retificadores.
losses in the
Depois da aplicação de
rectifiers and the
hidrogênio,
transformers.
tipicamente, né,
And
qualquer que seja
typically,
a aplicação de hidrogênio, você vai ter
in
que comprimir esse
every
hidrogênio.
application of the hydrogen,
Essa
you
unidade
need
de
to
compressão
compress
vai ter
this
motor
hydrogen. You'll
elétrico, você
have
vai
an
consumir
electric
energia
motor
elétrica.
to
Tipicamente, você tem
provide
que,
pressure for
em
compression.
algumas aplicações, aumentar a
You'll need
pureza
to
do
increase the
hidrogênio. Ele
purity,
sai do
so it
eletrolisador
leaves the
com
electrolyzer with
99,9% puro, mas
99.999% of
tem
purity,
aplicações,
but
por
we have
exemplo, com
applications
produção de amônia, que
for
você tem que
ammonia, for example.
aumentar
You
essa
need to
pureza,
increase this
tirar um pouquinho
purity
de
to take
oxigênio
out
dali,
oxygen
né? Isso
residues,
vai consumir um pouco
and
de
it will
energia elétrica.
consume a
E além
little
de
bit
ter
more of
sistemas,
energy.
tem automação,
And we have all
instrumentação
the
da planta.
systems,
Por exemplo,
automation and
a planta de
instrumentation,
hidrogênio
so the
completa, né, uma caixa preta,
the
né,
complete the
o
complete
número
box
típico,
of
né, que a gente costuma
hydrogen
chegar é
plant. So the
4,9
typical number is
kWh
4.9
por normal metro
kilowatt
cúbico.
hour per
Ok, obrigado.
cubic nanometer.
Falando pouco
So,
de
and talking about
construtibilidade, né, como eu
constructibility,
disse, o nosso
our
conceito
concept,
é equipamento totalmente modular,
the concept of
né? Então ele
our equipment is
ainda
totally
não é
modular.
construído aqui no Brasil,
It's not
né? A
manufactured
gente
in
trabalha aqui
Brazil.
para isso, né, para
and
ter mais e mais projetos aqui no Brasil e realmente um dia viabilizar
and
centro
to
de
make
manufatura aqui.
feasible a manufacturing center
Mas ele é
here, maybe,
construído,
but it's
hoje em dia,
built
temos centro de
today in
manufatura na Europa,
manufacturing
principalmente.
centers.
Ele é todo construído
Uh,
em fábrica, montado, testado em fábrica, né? Você consegue fazer um
you can
comissionamento
do a
dele ainda na
commissioning
fábrica. Testes
at
feitos,
the
ele é
plant.
desmontado, né? Um módulo de 20
So
megawatts ele
the
consegue ser
20
desmontado em 16
megawatts
skids,
module, it
que
can
você
be
coloca em containers,
dismantled in
containers
16
grandes, né?
skids
De 25
that can be
pés,
transported in
e
some
embarca
containers,
para o
and then
site
you ship
de
them to the
operação, né?
operations
Chegando no site de
site.
operação, essa
So
remontagem,
in this
né, basicamente é ligar os
reassemblage, it's
módulos
basically
e ligar a unidade nas
to
utilidades, né, no
assemble the
fornecimento
modules
de
and
água.
to put
Tipicamente é uma montagem que você
this
consegue fazer em
mounting.
21 dias. Tá? Então, uma montagem rápida.
It's
Né?
a mounting
A gente
that you
sabe
can
que
do
o
in
custo, né,
20 days
de construção e montagem no
average.
Brasil é um custo
We
elevado.
know that in
Né?
Brazil
Então, a
this
gente
is
consegue otimizar isso
the costs
bastante.
are high.
Ok?
We can optimize this a lot.
Como eu falei, a gente temos já, né, já um histórico aí, né, uma carteira aí de pedidos aí sendo
We have a
desenvolvidos,
chain of
né, para vários clientes aí
requests
no mundo,
and a
dos
chain of
bancos principais.
solutions for
Como eu
these
falei,
main
o
players in the
último
world.
contrato
So the
assinado aí
last
foi da Unigel
agreement
Brasil, uma
has been
planta de
from
60
Brazil,
megawatts, né,
Unigel,
que são 3
a
módulos
60
desse eu mostrei
megawatt plant
para a planta de
with
amônia
3
que eles
modules
operam
for
lá
the
em
ammonia
Camaçari,
plant.
Senhor Luiz,
na Bahia.
They
para
operate at
conclusão.
Camaçari in Bahia.
Obrigado. Então, falando
And just
rapidamente aí
quickly
da Unigel,
reminding you, quickly talking
uma
about
planta que vai ter
Unigel, it's a
capacidade
plant
de
that will have a
9.300
capacity of
toneladas por ano de produção de
9,300 tons
hidrogênio,
per year
né?
of
E isso
hydrogen,
vai conseguir
and it
gerar,
will be
em
able to
termos de produção de
generate in terms
amônia
of
dele,
ammonia,
né,
green
para a
ammonia,
Unigel,
for
55 mil
Unigel,
toneladas
50,
por ano. Né?
55,000
Então,
tons per
ok,
year. So
obrigado.
thank you
Só
very
para
much. For the
finalizar,
sake of time,
também
just
temos
to
aí
wrapping up
dentro
here,
da ThyssenKrupp,
we have inside
desenvolvimos
ThyssenKrupp the
competências para
technologies and
várias
competencies
aplicações downstream do hidrogênio,
for
né?
downstream
Principalmente
hydrogen
amônia e
applications.
metanol
So
verde, que a
green
gente conseguimos
methanol,
aí
ammonia,
integrar essas
we've been
soluções
able to
para os
integrate
projetos
these
no Brasil.
solutions for the
É
market
isso aí. Muito
projects. Thank
obrigado.
you very much. Thank you, Luis.
Obrigada, Luiz. O Luiz,
Luiz
ele
is
gerente de desenvolvimento de
business
negócios da
developer,
ThyssenKrupp. E, como
a
eu
business
falei, tem
developer,
ajudado muito a
business
fomentar esse
development
mercado no
manager with
Brasil. Esse
ThyssenKrupp.
contrato com a
This
Unigel
Unigel
é
project
também
is
um
a
marco, né, na
milestone
história desse mercado
in
no país,
our
porque é o
country because
primeiro
it's the first
contrato de
contract of green
produção de
hydrogen
hidrogênio
production
verde
in
em uma
an industry
indústria,
at
né, em
Camaçari,
Camaçari,
in
na
Bahia,
Bahia, na
the state
Unigel.
of Bahia.
Então, eu
I
considero
consider it
um
to be
marco
a
nesse
milestone.
setor. Eu
I would like
gostaria
to
de pedir
apologize
desculpas para a
with
empresa
Green
Green
Power
Power
Hydrogen Group.
Hydrogen
It's
Group, que é uma empresa
an
inglesa.
English company, Mr.
O senhor
Kamak.
Kamak também
They will
está participando
participate in
desse
this panel
painel
online.
online.
But let's talk Marina
Mas
Piva, that is
vamos chamar,
participating
então,
online
a
as well,
Marina
of
Piva,
the
que
lecture.
também
So
está participando
fostering
online, com a
green
palestra Impulsionando a
hydrogen
Revolução do Hidrogênio Verde
from
da
hope to
Esperança à
reality.
Realidade.
Marina
A Marina é
is
engenheira de
works with
aplicação da Unidade de
Siemens
Soluções de
Energy Green
Hidrogênio Verde
Hydrogen
da
Solutions.
Siemens
Thank you, Marina,
Energy.
for your
Obrigada,
participation.
Marina, pela sua participação.
Oi, gente, bom dia. Meu nome é
Hi,
Marina.
fellows.
Eu
Morning. My
trabalho
name is
como
Marina. I
engenheiro de
work as an
aplicação
application
na Siemens
engineer
Energy, na unidade de negócios que a gente
with
chama de New
Siemens
Energy
Energy.
Business,
We
focada nas
call it
soluções de hidrogênio
green
verde,
energy business.
principalmente hidrogênio
So
verde. Sou
for green
formada em
hydrogen
engenharia
and
química
derivatives, I'm
também, estou na
graduated
Siemens
in
desde
chemical
2019
engineering, and I work with
e vim
Siemens from
aqui
2019.
compartilhar um pouco
And
com
I'm
vocês
here to
sobre
share
a
a little
nossa
bit with
visão
you
da economia de
about
hidrogênio
our
verde
vision
e
on the
das
green
tecnologias para a
economy
produção de
and all the
hidrogênio
technologies
derivados.
related.
Bom,
Well,
a
here
gente vê que toda
we see
essa
that all
movimentação
these
da
movements
economia do hidrogênio verde tem
towards
trazido muita
green
esperança,
hydrogen
não
economy
só no que diz
has
respeito à questão
been creating a lot of
da
hope, not
sustentabilidade, mas
only
também
regarding sustainability, but
do que
also
ela
regarding
pode
the
trazer
economic
para a nossa
leverage.
economia e
So
dar destaque
bringing
aqui para o nosso país, né,
highlights
para a nossa
to
região da
Brazil
América
and Latin
Latina.
America. And I
Então,
would
eu
like to
queria falar um
share
pouquinho
how
sobre como a
we
gente
assess this hope and how this hope can become a reality, and what we are doing to contribute for this. So starting with this macro vision of the green hydrogen or the hydrogen economy, we see hydrogen as a key piece for the decarbonization of the several sectors within economy. We have a great amount of CO2 coming from other sectors, not only the electrical one, but the sectors like the industrial and transportation, civil constructions, etc. And in this context, those sectors, they have much more difficulty using renewable energies than the electrical sector itself. So the electrical sector, renewable energy for electrolysis is a pathway to help this renewable energy source to arrive to the several sectors. But we believe that the transformation in hydrogen of the hydrogen in other molecules is fundamental. In terms of electrolysis, we see as a more feasible pathway, the technology we bet on is the pay electrolysis. And in terms of application, we see a lot of potential of the hydrogen for decarbonization in industries with difficult emissions to mitigate. For example, the steel milling industry, chemical industry, it's very relevant, highlighting the ammonia production. So um, for the transformation of hydrogen in other molecules, we see this as a fundamental stage to make decarbonization feasible. When we talk about hydrogen exportation and thinking about our local application, these war situations show the importance of ammonia for our country. And then we see the electrolysis process sum to the Haverboat for the ammonia synthesis is very important to add value to this chain, um, to make this sector more sustainable and to make us not dependent anymore and on importation of ammonia. And so we have the capacity to integrate a comprehensive solution for hydrogen and derivatives. And talking about the derivatives, they are very important to the mobility sector. So, and in a complementary fashion, we've been observing development using the hydrogen directly as a fuel, focused on light vehicles. So the vehicles like small cars and or buses or lorries, uh, low size lorries. And when we think about heavy vehicles like wagons, like heavy trucks we have in Brazil, for example, of more than 100 tons of capacity, and also for aviation, we see that it's fundamental this synthesis of other fuels from the hydrogen from liquid fuel in order to profoundly decarbonize the operations for the vehicles to be to have their own the internal combustion engines, and it can be done combining the hydrogen from the electrolysis with the CO2 that can be captured from an inevitable emission source, for instance, and from this we can synthesize, for example, Fischer-Tropsch processes, a wide range of fuels like diesel, like SAFs, and to explore these more deep decarbonization within all the operations. And also methanol has a very relevant role and it can contribute with these e-fuels, so the E for energy, renewable energy. Converting methanol in other fuels, we have a reference case in this sense, the Caruone project in Chile, and the hydrogen is converted in methanol with the CO2 from the atmosphere and then in other byproducts. And in terms of technology, we see as very important all these synthesis, chemical synthesis chain from the hydrogen, and Siemens Group is a very traditional group in Brazil. We are in Brazil for more than 100 years, and we have all this history um, uh, of having this more comprehensive structure of the company that makes us to be able to go beyond electrolysis. And in terms of our electrolysis technology, we've developed this technology for more than 10 years. We call our equipment of Silyzer, so Siemens electrolyzer. The first version was of 2011 with 0.1 megawatts, and each 4 or 5 years technology took a leap of 10 times of in terms of power, and the efficiency has been improved as well. In 2015, we've launched Silyzer 200, and 2018 the third version, Silyzer 300, increasing 10 times, so from zero point 0.1 to 1 megawatts of installed capacity, and now our current version of Silyzer is 300, and we are in the tier of 10 megawatts. And the trend to the next years is to continue to take these leaps, and we imagine an order of power of 100 megawatts for 2023, and for 2028 and plus, we'll start projects in the tier of 1,000 megawatts. And to serve these demands, and we are focusing on the technology, cutting edge technology, because this is the pathway to achieve hydrogen with the best price possible. So going to these major scales, the hydrogen price will be each day more competitive. And this is how we see the projects becoming each day more feasible. And to address this demand, we keep working with Silyzer 300 technology, but we are preparing ourselves to change our production to a new plant, and we call it Gigafactory. So we'll have electrolyzers, so Silyzers 300 simultaneously working together in the tier of gigawatts. So, and that will be as of the middle of the next year. So in 2023, in 1 year, we'll have the capacity to deliver 1 gigawatt, and we'll increase 1 gigawatt per year, depending on the market demands. And the concept is to have those prefabricated, precast groups, and the plant concept pre-sketched, and to produce the electrolyzers in scale, and also bring in more competitiveness for the electrolyzers capex that has an impact in the project's competitiveness. And currently we have a factory running that is we have projects of reference with Silyzer 300, and our expertise here in the Brazilian market is to have, with our more than 100 years experience, so as a way of complementing the expertise in the manufacturing in Germany, and to address the best way possible are the local market solutions that will be very relevant for the for the hydrogen economy, not only as providers for the global market, but we also believe and see a potential for using locally all the hydrogen byproducts. Thank you for your attention, and we will keep up. I'll meet you again by the Q&A session. Thank you very much.
Obrigada,
Thank you,
Marina.
Marina.
Eu vou chamar agora
I'll call
Daniel
in Mr.
Lopes,
Daniel
ele é
Lopes.
diretor
He's
da Hydron
High
Energia e
Director
Gases
for Hydrogen
Especiais do
Energy.
Grupo Neumann Nessa.
Bom dia a
So,
todos
morning,
e
everyone,
todas.
and
É um prazer enorme estar aqui
it's a
com
great pleasure
vocês.
to be here.
Não apenas para poder falar
Not
em
only to
português,
talk
mas em
in
cearense
Portuguese,
também.
but
Eu
in
sou
my local
cearense,
dialect,
orgulho
the,
enorme.
the dialect of our state, Ceará.
Sou engenheiro mecânico,
I'm a
formado
mechanical
pela
engineer,
Universidade Federal do Ceará.
graduated with Federal
Saí daqui em
University of Ceará. I
2003,
left
muito
my state
incentivado
in
pela professora
2003
Maria Eugênia,
with
que foi minha
the
orientadora
blessings of
de
my
graduação
professor
e que já era
Maria
responsável pelo
Eugênia.
laboratório de energia
She was
solar da
responsible by the
UFC naquela
time
época.
for the solar
Para
energy
trabalhar em
lab
2003
with
no meu
UFC,
mestrado no
to
laboratório de
work in
hidrogênio da Unicamp,
2003 in the
com o
hydrogen
professor Enio
lab
Pérez da Silva.
at Unicamp
E
with Professor
cheguei na Unicamp
Enio
em
Pérez
junho de
Silva.
2003
I
e
arrived there in June
fundamos em novembro de
2003, and in November
2003,
of
do mesmo ano,
2003, the
a
same
Hydron,
year, we founded
que
Hydron,
surgia como um spin-off do laboratório de hidrogênio da
emerging as a
Unicamp.
spin-off
Então, uma
of
honra
the
enorme
Unicamp Hydrogen Lab.
de ter
So
sido uma das
it's been
pessoas
an
que trouxe
honor
a ideia do
being the
hidrogênio verde
person
para
who
o
brought
Ceará
the green
em
hydrogen
2019,
idea in
uma conversa com o Maia Júnior,
2019, talking
com o
to
Júlio,
Mr. Maya
com
Jr.,
aprovação, com apoio do
and
Hugo,
with
do
we've
Segais,
had the support of
do Jurandir
Hugo,
Picanso e
Dr.
de todo o
Jurandir
time brilhante
Picanso,
que
and
está por trás,
Segais, and the
Joaquim
brilliant
Rolim, etc.,
team,
Fiec,
Joaquim Rolim
o
and Fiec,
resultado, tudo que a gente está vendo acontecer hoje.
everything we're seeing
E ontem eu
today.
fiquei super emocionado
And I got very
quando a Mônica
emotional yesterday when
foi
Monica
congratular pela nossa casa
received the
internacional,
award
porque realmente ela fez
because
muita
she
diferença
deserved
pra
it.
gente nessa
She's been making a difference.
trajetória.
And
Super feliz de dizer, né, que eu até me
I'm very
emociono todo
happy
dia.
to say, and
Em
I
outubro de
always get
2020,
emotional
como a
when I
Mônica
say
comentou,
this. In October
numa
2020,
reunião que estávamos eu, a
in a
Mônica
meeting
e o Ansga da
with
HK, né,
me,
da
Monica, and Ansga
campanha,
from HK,
no mesmo dia, no
in the
mesmo
same
horário
day, the same time
que o Jurandir estava
that Jurandir
dando a
was
oportunidade da
giving
gente
the
mostrar para a
opportunity to
Fiec
us to show
uma
Fiec
visão global do
some
hidrogênio.
global
No
view,
mesmo dia, no
an
mesmo
overview,
horário,
global
o
overview of
Jurandir Picanso
hydrogen in
Neto,
this by the
o
same
Jurandir
time.
estava operando meu pai com
Jurandir
câncer
Picanso Neto
no
was
rim.
operating my
E deu
dad
tudo certo, graças a
of
Deus, mas eu achei que aquilo
kidney
foi um marco
cancer.
para mim pessoalmente, que estava
It's
eu
been a
e o
milestone. I
pai,
was,
o filho e o pai no outro lado ali,
my
cada um
dad
na sua
was
área
with
se ajudando,
his
né? Então, isso também
grandson,
traz
and I was with
um pequeno
him.
ponto ali
So this
mas essas
brings me
coincidências elas não são, né,
a
precisam ser relembradas de vez
coincidence
em quando.
framework that
Bom,
is
a
very
Hydron
important to me.
é uma
So
empresa brasileira,
Hydron is a
desenvolvedora da
cutting-edge company
tecnologia
in
inteira
Brazil.
no Brasil.
I'm very
É um
proud
orgulho
to
enorme
say
de
that,
falar que
well,
quando os
when
meus
our
professores
teachers, our
incentivavam a
professors
gente,
would
dizer, olha,
say,
poxa, a
well,
gente tem que fazer a
we
diferença
need
pela
to
engenharia
make the
brasileira,
difference
um sonho
for
que a Hydron
the green
conseguiu
hydrogen
fazer.
in Brazil, okay? And
Nós
that
conseguimos
was
desenvolver
Hydron
tecnologia
is doing, and
e
we've been
vender
able to
tecnologia para a
sell
Alemanha
technology
a partir
to
do Brasil,
German, and Hydron
né?
is
Hoje a Hydron
trying
tem um sonho de se
to
tornar
get
global,
global, and we're
passa a ser
making part
parte
of
do grupo Neumann
group
Nesser,
Neumann and
grupo alemão,
Esser, a
uma
company
empresa
family
familiar
of
de 192
192
anos,
years of
líder
history, a global
global
leader
no
in industrial
fornecimento de
processes, mainly
compressores
to
para os
hydrogen.
processos industriais, principalmente para o
Some
hidrogênio.
clients of
Alguns clientes
NEA,
da NEA já me
NEA
falaram
is
que eles
deemed to be the
consideram a
mother
NEA
of
como a
the
mãe
industrial
dos gases
gases.
industriais no
They
mundo,
made
porque foi
feasible
quem viabilizou
gases
a
compression
compressão dos
globally.
gases industriais globalmente.
In this their
Dentro dessa
strategy, they've
estratégia
acknowledged in
do grupo NEA,
2020
eles
that with all
perceberam de
this
2020
history, all this
que eles
responsibility,
poderiam, com
almost
todo esse
200 years,
histórico, com toda a
to include in their
responsabilidade que eles já
portfolio
tinham, quase
the production of the
bicentenária,
hydrogen, not only
incluir no seu
compression,
portfólio
and
a
Hydron
produção
has
do
been
hidrogênio,
chosen
não apenas a
amongst all.
compressão, E a empresa escolhida no mundo foi a Hydron,
With this,
a tecnologia no portfólio da Alemanha.
we
Com isso,
passed through
a
all
gente
the value
passa
chain.
a tomar
So
toda a
the
cadeia
NEA
de volta
group
do hidrogênio.
has a company, a branch called
NEA
Arcano
tem uma empresa chamada
that is
Arcano,
responsible
que
in
ela
Germany
é
to produce
responsável na
biogas
Alemanha
and
por
methane.
produzir biogás
Since this
e
biogas and
biometano.
methane are
Uma vez que esse
produced,
biogás, esse biometano, ele é produzido,
the
os compressores da
compressors
NEA
from
ajudam a serem utilizados em
NEA,
processos
NEA,
industriais
that is NEA,
diversos.
and
Entra um equipamento da Hydron que produz
they are
hidrogênio.
the machinery.
Acerta o botão.
They
Que produz
provide the
hidrogênio
machinery of
a
choice
partir, por
for all
exemplo,
these
do
compression
biometano.
procedures. And for being
Então
a
a Hydron,
Brazilian
por
and
ser uma empresa
to be
brasileira de
a
engenharia da
global
agência brasileira, a gente
provider of
tem selo no
choice in
Centro de
hydrogen
Excelência
production,
Global do Grupo Neumann Enesco
a
na
Brazilian
produção de
company
hidrogênio.
must
A
be
gente teve que ser versátil.
versatile, must
Uma
be.
empresa brasileira tem
We
que ser
cannot
versátil.
depend
A gente não
only
pode
on
depender de uma única
big
tecnologia.
plants. We need to
A
be
gente não pode depender só de plantas
flexible to
grandes.
serve
A gente tem que ter
various sectors. So
maleabilidade
Hydron
para atender
developed three
diversos
types of
setores.
technology:
A Hydron, então,
water
desenvolveu 3 tipos de
electrolysis,
tecnologias. A
the
eletrólise,
renewable
eletrólise da
energy
água,
production
vou falar um pouquinho
systems
mais sobre
from
isso. Os
biomethane, from
sistemas de produção de hidrogênio
methane.
renovável a partir do gás do biometano.
We are one of the only
Outra
company in the
forma
world
onde nós
producing
somos a única
renewable
empresa
energy
no
from
mundo atualmente a
ethanol.
produção de
Our
hidrogênio
country,
renovável a
Brazil,
partir
is
da
the
etanol.
ethanol production
Aqui
leader.
vamos ser diferente, né? Nosso país é
Uh,
um dos
and
líderes.
as the hydrogen is
Bom, uma vez que
produced,
o hidrogênio é
it can
produzido,
be
ele pode ser
compressed
comprimido
with
novamente pelas máquinas
NEA
da NEA
machinery for
para
several
diversos
uses,
usos.
automotive
Transporte,
usage,
armazenamento,
so
uso
natural gas
automotivo,
pipeline. It's a dream of us to
colocar
do
numa
this with
pipeline de gás
Cegas,
natural,
the
por exemplo.
Ceará
Nós
gas
estamos com o
company,
Google aqui para fazer isso
and
nesse
to
gás.
convert this hydrogen in electricity
E também
when
até reconverter esse hidrogênio em
demanded.
eletricidade, quando requerido pelo nosso cliente.
I won't
Bom,
get
falando
into
pouquinho dos
details,
equipamentos da Hydron, eu não vou entrar no detalhe,
and
mas eu acho que eu estou totalmente à disposição para
but
fazer
in order to
dimensionamento para
make the
cada uma das
proper
tecnologias que a
dimension,
gente
we work
desenvolve
with two
juntos.
technologies:
Nós trabalhamos com duas
the PEM
tecnologias, a
technology
tecnologia
and
PEM,
the
eletrólise,
alkaline technology.
e a tecnologia
In both
alcalina.
technologies, we
Em ambas
work
as
making
tecnologias, nós já
available
trabalhamos
pressurized
disponibilizando
hydrogen,
hidrogênio
offering in
pressurizado,
PEM hydrogen at
ofertando na
40
tecnologia
bar
PEM
of
hidrogênio
pressure,
para 40 bar,
and with
sem
the
necessidade de compressão. A gente vai
ALK
chegar nessa
30
função. E a
bar
tecnologia alcalina,
or bar in
30
terms
bar.
of
Quando a gente está falando de
measuring
de
unit of
reforma
pressure.
de
We work
biometano
when we
e
work with
etanol,
methanol and
também
ethanol, we
trabalhamos
work
com
with
hidrogênio
high
de purezas
purity
elevadas.
hydrogen, and we work
Dada
with
os
the
requisitos
purification
de
of these
uso do
gases
hidrogênio, a gente
through
trabalha
our
com
machinery.
purificação desse gás também nos nossos equipamentos.
The NEA solution is different from our
Então, a
fellow
solução da NEA é
Germany
diferente da solução dos nossos outros
providers.
amigos aqui da
This
Alemanha.
is a tailor-made
Ela é uma
solution.
solução tailor-made.
We have
Então,
a
a gente
minimum
faz todo
size,
esse
obviously, to
Lógico, a gente tem
10
tamanho mínimo de produção do equipamento
normal cubic
para
meters
10
per
normais
hour
de
and
cúbicos
normalized
por
in
hora e
systems of 1,000
modularizado em sistemas de
normal
cúbico
cubic
normal, mas
meters
cúbico
per
por hora,
hour
onde temos já feito
in
sistemas,
with our
projetos
clients
e propostas para
with
nossos clientes de
businesses
centenas
more
de
than
megawatts.
100 megawatts.
Os diferentes tamanhos importam para a
This
gente, porque no
technology
Brasil e no mundo ainda é
must be
necessário ter
inside
muita
the university,
demonstração. A
must
tecnologia
be
precisa estar dentro da
tested
universidade,
every
precisa estar
day,
dentro do
tested
setor
and
sanitário,
assessed every
precisa estar
day
dentro do Fraunhofer,
on
precisa
how
estar
to improve
sendo
costs
testada e avaliada como
and
ela vai
prices,
melhorar
and we
custos,
understand
melhorar
that different
preços. E
applications
a gente entende
need
que
different solutions,
diferentes
and we're
aplicações
prepared
necessitam de diferentes
to
soluções. E a
serve
gente está
these
preparado
different
para atender essas
sizes of
diferentes formas.
businesses. We have a
No
Neumann and
Brasil,
S
nós temos uma fábrica em
plant
Minas Gerais,
in the state of Minas
Grupo
Gerais,
Neumann
where
Enesco,
we are
onde a gente já está
investing
aumentando a capacidade
dozens of millions of
produtiva,
reais,
dezenas de milhões de
and will
reais.
be able to
No final de
produce
2023, a
70
gente vai ter a
megawatts with the
capacidade de produzir
module
70
technology
megawatts
in
da
containers
tecnologia modularizada
in our
aqui
own
com
factory,
dentro
in
da
our
nossa
own
própria
plant.
fábrica. Claro
But
que
the
as tecnologias
multi-megawatt technologies are
multi-megawatt, elas são
assembled
montadas em
in the
campo.
field, and the amount of
E a
power we
expansão,
can make available is much bigger than
de
that. In
potência que a gente vai
2024, in
conseguir
Germany,
colocar
we'll have
isso.
a capacity of 300
Em
megawatts for
2024, na Alemanha, a gente
modularized
já vai ter uma
solutions
capacidade de
in
300
different
megawatts
sizes,
para
and with the
soluções
detail of
modularizadas em
providing the
diferentes formas.
comprehensive solution, not only
E
the
com um detalhe,
electrolyzer, but
fornecemos
optimized
a
with
solução
all the
completa, não
compression
apenas o
systems.
eletrolisador, mas otimizado com sistemas de
Now
compressão, etc.
we are going to talk about the
Agora eu vou
projects
falar
in
de como
Brazil.
é
I've
no Brasil. O
separated
que
the
está
main
acontecendo
projects to
aqui com a
show
gente,
you
onde que a gente está
our
envolvido. Eu
reality in
separei os
Brazil.
principais projetos para a gente
And
demonstrar
first of all,
a nossa realidade
that
aqui no
is very
Brasil,
important.
né?
It's a project with
Então, primeiro de
EDP.
todas,
The
que é
first
super
project
importante. O projeto
in
vai
a
ter
megawatt
o
scale.
primeiro projeto de geração de hidrogênio verde
It's
no
happening
Brasil em
now,
escala de megawatt.
and it's
Está
ongoing, and
acontecendo
it
nesse
will be
momento
deployed
e
in the
vai ser
port,
instalado no porto do PECEM.
the port
As primeiras
complex
moléculas de
of
hidrogênio vão ser
Pecém,
produzidas esse ano. Caio está aqui, o Diego
with
está aqui da EDP
EDP,
representando
and it's
esse
been an
importante
honor
projeto.
to
E
having
uma
been
honra para a
chosen
gente poder termos sido
for a
escolhidos
very important group,
como uma
not only in
referência num
Brazil,
grupo tão
but in the
importante
world, and we'll be
de
here
líderes não só no
together
Brasil, mas
to
no
make the
mundo.
difference with
E estaremos juntos
EDP
aqui para
and
fazer
the
diferença com a EDP
state government
e com o
for this
governo do
hydrogen to
estado
be
para que esse
used
hidrogênio seja utilizado em
in
diversas
different
formas,
ways and
que a
to
gente possa de
test
fato
all the
começar a buscar
off-takers
off-takers e
and
como a
how
gente vai
to
expandir
expand
isso,
this
né,
in the port, within the
porto,
state.
no estado
It's a
e
system that will
liderado aí
produce
pela EDP.
250
É um sistema que vai
normal
produzir
cubic
250
meters.
cúbico por hora de hidrogênio, isso é bastante hidrogênio.
So it's a milestone that we need
Então
to
esse é um grande
cherish a
marco que a gente
lot.
vai ter que valorizar
So
muito aqui no nosso estado,
because
porque
we started
assim
everything
podemos fazer
here
o
through
start
our
disso tudo
state.
acontecer por aqui.
We have an important
Certo?
project with Repsol. It's a project of
Nós temos
Power
importante
2X,
projeto com a Repsol,
where we produce
que é
renewable
projeto de Power
energy,
2X, onde a gente produz hidrogênio
water and
renovável,
CO2
água
to
e CO2
produce the
para produzir o
e-diesel, for
combustível
example.
renovável, o e-diesel, por exemplo.
And it's
Piloto desse
been
projeto
deployed
ele
in
está sendo
Hytron in
instalado na
Sumaré,
Hydro. A
Campinas.
Hydron fica em
It's our
Sumaré,
tech
na
center.
Campinas,
You
e lá é
can
nosso
visit
centro
us.
de
You're all
tecnologia.
invited and
Fica o
verify
convite, vocês
how
podem
we
visitar a
develop
gente
those
e
technologies
verificar
in-house,
como a gente desenvolve essas
in-housely
tecnologias e como a gente demonstra essas
before
tecnologias
taking them
in-house
to the field.
antes de levá-la para um
And
tamanho de
we, in this
demonstração.
project, we
Nesse
will
projeto,
produce
a gente vai chegar na
e-diesel
produção do
and the
diesel
first
verde a partir do final desse
e-diesel
ano,
liters
começo do ano que vem.
Brazilian produced
Então, os primeiros litros de diesel e
will be
brasileiro
produced by the end
já
of this year,
estarão sendo
beginning of the next.
produzidos no começo do ano que vem,
And together with
no
partnership
final
with
desse
the
ano,
GIZ, and
junto de uma parceria com a
we
GIZ,
will
no
elevate
programa ProQR, a gente
or
vai
step
levar
up this
esse
diesel
diesel até
for
a fase de avaliação
SAF
também na unidade piloto.
utilizations.
Que
That's been a dream
o
of
nosso
us
sonho,
together
o
with,
nosso esforço,
and a dream of
o nosso
us
orgulho
is to
é de
bring the
fazer
demonstration of this
desejo,
project
é
from
de
the
trazer a
pilot to
demonstração
the
desse projeto,
demonstration
já
part
saindo da
for
escala piloto
the
para a escala
government of
demonstração,
Ceará for
também
the
aqui para o
production of
território do
SAF,
estado do
so
Ceará,
renewable SAF,
para a produção de
using
querosene de
renewable
aviação
electricity,
renovável,
so green
utilizando
hydrogen,
aqui a
renewable
água
energy, green hydrogen, and
para
CO2
liqueficar
capture. So
produções. Então,
we hope these
nós
pilots
esperamos
can
que isso daí
leverage
seja de fato uma
all the
alavancagem desse
efforts.
piloto que está sendo feito na Hydro. E
So
já temos um esforço conjunto nesse sentido.
the first
A primeira HRS,
hydrogen refueling
a estação de
station,
abastecimento veicular
it's
do Nordeste,
been
já está
approved
sendo,
with
foi um projeto
Thermop, a
aprovado em
company
março
from
desse ano
Iberdrola Group,
com a Thermop,
partnership with
que é uma empresa
Hytron.
do grupo Iberdrola, também
We're
uma
delivering
parceria com a Hydro, e a gente está
the production of hydrogen,
entregando a
its
produção do
compression,
hidrogênio,
its storage. So it will be
a
connected
compressão, o
with
armazenamento.
in the pipeline of thermal
Lá vai ser
pipeline and with
conectado no
dispenser
pipeline
for
dentro da própria
mobility
Iberdrola.
application. So we
E
start
o dispenser para aplicação em mobilidade. Então,
with
a
the
gente já
first
começa a
vehicle
ter as primeiras
stations
estações de
for
abastecimento veicular
battery juice
no Nordeste,
with
também com
Brazilian
tecnologia
technology.
brasileira.
And if it was not
Não
enough,
bastasse, a gente também
we
traz
put
boas
ethanol
notícias.
in
A
the
gente vai colocar
global
o
hydrogen
etanol na
distribution
rota da distribuição do
route.
hidrogênio global.
We have another options
Ou seja,
besides green
a gente tem
ammonia,
outras
besides
opções
green
além da
methanol.
amônia verde, do metanol verde, que a gente também trabalha nesse sentido. Mas a
And
gente
we believe
acredita
that
que o
ethanol
etanol
can be deemed
também
as
deve
green
ser
hydrogen
considerado como
carrier
green hydrogen
because
carrier,
ethanol is
porque
so hydrogen is
transporta
not
etanol,
toxic,
ele é um
it's
combustível que não
renewable.
é tóxico,
We can transport
ele é
easily
um
these
combustível
Brazilian
renovável, a gente consegue
fuel, and
transportar
then we
facilmente esse
introduce
combustível brasileiro e a gente
in our
introduz
agribusiness sector.
o nosso
We
agro,
introduce
o setor
globally
agro brasileiro,
our
na
agribusiness sector
tecnologia de hidrogênio globalmente. Então nós
with
vamos
the
anunciar
green hydrogen.
globalmente esse
I
projeto em
cannot
setembro. Eu ainda não posso
disclose
falar
much
muito
more,
mais do que isso, mas daqui a um mês a gente vai estar
but
publicando
this
globalmente.
hydrogen
E esse
project
projeto
is
é da Hydro, com uma das
we are
líderes
playing with
brasileiras e global do setor de
alcohol
açúcar
and
e
sugar
álcool, uma
companies
empresa de
and
petróleo
with other huge
enorme,
partners. So in a month,
que está de
all the
fato
information will
financiando esse
be
projeto.
disclosed,
Em breve,
and
daqui a um
next
mês,
year I will bring
todas
you
as
all the
informações a respeito desse projeto
details
poderão ser divulgadas.
all the details associated, though, and just we've recently contracted a project with Com Gás to demonstrate the green hydrogen production from biomethane, to put the biomethane sector and with several diverse and various usages for hydrogen in the chain of the biomethane usage for the hydrogen. So we work with the competencies we can assess in Brazil, we can identify in Brazil, and with the complementarities of the hydrogen. So just wrapping up, I can announce to you this scalable plant with an outcome of 100 megawatts, including green ammonia production, focused in the dissemination of this knowledge and capacity building of people that will work in the multi-megawatt plants with a scale, in a scale that we get joint knowledge. And then next year, we will be able to announce these projects as a kickoff in 2023. So these are our NEA and Hydron projects, and with this, I invite you to access our website, Agile Solution Experts, and then you can find more information on our projects and on our technology. So, and once again, Monica, thank you for the invitation. Thank you all the attendees. Thank you all my fellow citizens involved in this project. Thank you very much.
Obrigada, Daniel.
Thank you, Daniel. I would like to take advantage and to thank these three companies, Siemens Energy, Hydron, and ThyssenKrupp, because those three companies, they've contributed with the green hydrogen introduction course with Senai. Senai is a partner of Fiec. And ThyssenKrupp, Siemens Energy provided material, and Daniel was a lecturer. So leaflets, audios, specifications, Hydron as well, for the students. Then they could be able to access this material as a virtual exhibition. And I thank these companies again, and when in the final remarks, I will tell you, I will launch a challenge to you. And now I will call in Mr. Marcan, developer for Clean Power CPH2. Mr. Kama, please.
Yeah, thanks for giving us the opportunity to present today. Being involved with the Fiec in Brazil, we're really excited about the Brazilian hydrogen economy, and we would be very honored to be a part of this growing economy and support the hydrogen transition that you're involved with. So I'll start my presentation shortly with a quick introduction and the business development manager at Clean Power Hydrogen. My background is engineering. I have a master's.
Engenheiro, eu tenho mestrado também em engenharia e tenho trabalhado aí nos últimos 2 anos com isso.
Right, so an overview of the presentation is basically I'll introduce the company. I'll give you an idea of the direction of the business, the markets that the company can potentially support, the methods of producing hydrogen, where we fit into the hydrogen industry, and an overall and an overview of the electrolyzer and how it works. Thank you. So a bit of background about the business. We started off in 2012. Actually, I'll take a step further back. Our founder of the business, Dr. Nigel Williamson, used to work for a reputable PEM electrolyzer manufacturer, and he developed their technology. And during the development process, he realized that some of the things with membranes is that they're expensive. You know, they're prone to failure, and they can be very expensive to mine. So sustainability becomes an issue. So Dr. Nigel Williamson wants to develop a company that didn't rely on membranes. Hence the reason Clean Power Hydrogen was formed. We were formed in 2012 in Ireland, and between 2012 and 2020, the company has grown massively. We did R&D. We've built demonstration units, but 2020 was our main transition point from an R&D business to a commercial business. So where we are now as a business, we have made multiple sales. So we made 6 sales, and one of the sales actually has gone into South America. So it's a 1 megawatt unit, and I will show you what a 1 megawatt looks like later on. We've gone from a small team to a big engineering team. We've actually on the stock market. So the business is growing in accordance to the demand of the hydrogen economy, and we are not just supplying into Europe, we're supplying globally, and part of our transition and growth is to actually partner with potential clients, customers in different parts of the world, to not just to sell our electrolyzer, but also to build our electrolyzers within that country as well. So we are looking for people who can license our technology to as well. So it's something to keep in mind if you're looking to for the Brazilian or even the South American economy and as a whole, and looking for partners. We would definitely be willing to have a conversation around that. So this is a very high level overview of the business transition. So that was the team when I first started 2 years ago. If you want to know, I'm the person in the odd color shirt there. So we were only 7, 8 of us. And then during that time, we made a number of sales. So these are some of the customers that I can mention right now. And our first sale that we did was actually to Northern Ireland Water. So the Northern Irish Water Company took our electrolyzer, not for the hydrogen, but for the oxygen. And once again, I'll explain later on why that was the case. Then we scaled up, which is quite recent, 2022. So this is our new facility, it's a 30,000 square foot facility. We're manufacturing there our electrolyzers, and all the sales that we made are actually currently being manufactured there. And market share, naturally, we're a new technology, so people have not heard of us, they weren't aware of us. Now people are starting to learn a little bit more about us, and our technology is getting out there. All this is leading to gigawatt scale, and part of that gigawatt scale is that we want to be aiming 4 gigawatts worth of production by 2030. I know it's very ambitious, but our target is to aim for a 4 gigawatt facility or capability. And that capability doesn't just mean exports, but also with different customers in different parts of the world, to build our technology and contribute towards that 4 gigawatt for us, and also contribute towards the local economy. Here are some high level figures. I leave it to you to add up what a trillion looks like. There's so many zeros, so I don't know, but we're talking $10 trillion economy by 2050. So it's a huge opportunity. 500 gigawatts is the kind of figure people are talking about. So you can see there's an opportunity for all the technologies and everyone involved in the hydrogen economy. So as a business development guy, obviously I want whole 500 gigawatts, but that's not going to happen. But what I'm saying, that it's very exciting opportunity for us all to get involved in. So our markets, I think it's been quite eloquently spoken about the kind of markets that are out there, and we don't fall in anything different. This is just a very high level overview of the kind of industries that we can feed into, and we're just the electrolyzer, so we can connect to any renewable source or just the main supply. And the electrolyzer is our part there. That's our core technology, and that's the only aspect we do. And then we can supply into the various industries. And most of the industries have been mentioned, so I won't go into detail around that. Once again, most of you guys will probably know the methods of producing hydrogen, so I won't dwell into this. But the two common methods of producing hydrogen is SMR, steam methane reforming, and electrolysis. A couple of technologies have spoken about a couple of companies have spoken about the technologies. So where we fit into this mix is that we're an alternative to the existing technologies. We're a membrane-free electrolyzer. So from this point onwards, the presentation will be around our technology. So if you look on the right-hand side, you see the model of our design. Currently, what we're manufacturing in the UK is a 1 megawatt electrolyzer. A 1 megawatt electrolyzer footprint is 40-foot container where we have the balance of plant and where we have the control system and the AC to DC rectification all within the 40-foot container with a cooling system on the top. This is our starting model at the moment. Our aim is to scale up. Our aim is to scale up to 2 megawatt, then to 5 and 10 megawatt blocks, and we want to do that pretty quickly if we want to achieve our 4 gigawatt target that we've set. So where we differ is that we're membrane free, so that means we don't have any platinum group metals or any catalytic application to do the separation of hydrogen and oxygen. We separate our gases cryogenically. So what that means is that where the stack on the model, if you look at the model on the right hand side, the stack is the circular design there on the far left. What we do at that point, we just generate the hydrogen and oxygen. Then the gas is a mixed gas stream, and it goes all the way to the cryogenic system where the gases are separated. The way we separate our gases is that we lower the temperature of oxygen, so we liquefy oxygen, and then we allow hydrogen to escape in gas form, and then we regasify the liquid oxygen to make it a gas output. And this is what attracted Northern Irish Water. Because we separate the gases cryogenically, there's no membrane or catalytic process to do the separation, our gases are very pure. So we offer medical grade equivalent gas, oxygen, straight from our electrolyzer. So the water treatment facilities are very interested in that. So any of you guys who are thinking about a hydrogen economy, don't forget the oxygen, because the oxygen is a very useful, viable byproduct. And if you look on the top right-hand corner, a 1 megawatt produces 450 kilograms of hydrogen a day and 3,600 kilograms of oxygen. So you can see the amount of oxygen that's used. Produced. So it's worth keeping in mind that when you do a financial model of electrolysis, not just with any any electrolyzer, keep in mind the oxygen and the hydrogen. The other benefit of our technology is that we don't use super purified or really high purity water. We can use potable water or drinking water levels. Obviously, our design has been based on European design, so the European water level will be different to South America, North America, India, China, wherever. So we'd have to have a discussion, but typically we can accept potable or drinking water. We've offered one of the points mentioned here is we're offering a warranty of 25 years. That warranty, obviously, we've not been going for 25 years, but all our testing and development and everything has proven, because we don't use membranes and the kind of cell plates that we use, gives us a longevity on our stack where the hydrogen is produced, and which means your OPEX running costs differ entirely. And plus, because we've got no platinum group metals, we've got no catalysts and no membranes, we have a sustainability footprint where we don't have to mine products to make our electrolyzer. So that hopefully that gives you a good understanding of our technology at a very high level. So where we differ is that typical existing technologies that are out there now have lots of components within a cell structure. As I mentioned earlier, the stack is where the hydrogen is produced. The more cells you have, the bigger the stack, the more hydrogen you can produce. And any of these membranes or catalytic processes that occur in these technologies, any one of them could go faulty or fail. It's a very costly process, very engineering intensive and long lead items. So what we try to do with clean power hydrogen was negate all these components and simplify our cell structure So our cell structure is literally three components. It's a front plate, a back plate, and a gasket. And we have patents around our technology. So we have patents around the stack, we have patents around the cryogenic separation, and also around the whole process. So as in the bottom left-hand corner, it says simple, safe, sustainable. That's the kind of business case we're presenting. Is our technology is simple, we're safe, and we're sustainable. We're simple in another point of view as well, that we only have all the processes that we have in our technology are existing tech. So we have cryogenics, which has been around for many years. We have gas drying process, which is the stage before the cryogenic separation, which is existing technology. The difference is we've just got membrane-free electrolysis, and electrolysis has been around for many years. So really, all the stages in our electrolyzer, we're using existing technology and putting it together and doing some black magic to produce the hydrogen and oxygen. So the next slide will give you a video of how our technology works. So it kind of summarizes what I've just said, and that will basically conclude the technical side of the presentation. Hopefully everyone can see this and hear it.
Técnica da minha apresentação, espero que vocês vejam o vídeo de maneira satisfatória.
How does the electrolyzer work?
Vejam como a eletrólise funciona.
Water is fed in, mixed with electrolyte, and travels to the stack where the chemical reaction happens and the gas is generated. The mixed gas continues its journey through the balance of plant to the dryers. Powered by renewable electricity, the stack is fed electrolyte that contains hydroxide ions dissolved in water. Water in the electrolyte is consumed by the electrolyzer and is separated into hydrogen and oxygen gases by electricity. Put simply, the water molecules on the left show the hydrogen and oxygen atoms joined together. On the right, you see the molecules after being zapped with electricity. The wet gas enters the dryers. Desiccant removes the water from the mixed gas stream, and gas continues its journey to the cryogen for separation. The cryogenic system is where the oxygen and hydrogen are separated. The separated gases are passed through the purity meters.
Separados criogenicamente têm uma alta taxa
The
de
gas
pureza.
purities are measured and passed for use in an application or stored.
Ela garante uma série de aplicações.
For small installations, the whole process takes place in a purpose-built container, using renewable electricity, producing green hydrogen and medical-grade oxygen. Using green hydrogen to power and fuel everyday life will accelerate our progress towards a zero-carbon future. For us, for our children, and future generations. Find out more at cph2.com.
Para uma transição energética mais suave.
So that kind of brings me to the end of that technical side. So hopefully that kind of explains our technology from the diagrams and also from the video here. There we go. So the patent, this is just for information. We have various patents around the world. We're adding more and more because our technology has got a number of patents in it, so we have to protect it. We have it in the Americas region as well, and we're looking at adding more and more to South America. So yeah, that's where we are. And as I mentioned earlier, we have a project in South America, in Paraguay. We're hopeful that will be landing sometime end of this year, early next year. It's a 1 megawatt unit, which, as I said, is our entry point into the market, and we're looking to scale up pretty quickly to support the hydrogen economy. And yeah, here are my contact details, and I'd love to get in touch with you guys if there's any projects that you're thinking of or any further questions you have. There's going to be a Q&A session at the end. Feel free to ask. And yeah, once again, thank you very much for giving me the opportunity to present and being part of this event. Thank you.
Thank you very much, Mr. Kamar.
The costs of the electrolyzers and the OPEX costs, it's important to take into account the commercialization, not only of the hydrogen, but also of the byproducts of the electrolyzer. So there are hydrogen, oxygen, and heat. Also heat in Europe, people are using heat taking advantage of the heat generated in the electrolyzation processes, use it for heating houses, and so today, so everything. So far, this oxygen has been, released in the air. So the oxygen of the electrolyze processes have been released in the atmosphere. But and during the pandemic, oxygen value has been added, and this very pure oxygen has a great value not only for medicine but for all the industries. It's raw. It's a byproduct that is a raw input for lots of processes. So it's worth it to assess these three products: hydrogen, oxygen, and heat, taking advantage of the three of them. And at this point, I would like to add up, in Pecém we have a great oxygen consumer, that is the steel milling, the steel mill company, CSP. Yes, and steel mills are a great and good example because they consume both hydrogen and oxygen and maybe heat or not. Well, why not? Why not? Some processes. Well, I have a question here. We are finishing the panel, but I received a question from the journalist Egidio Serpa for Luis. So you know that the state of Ceará signed an MOU with 19 companies, and how many amongst those will feature electrolyzers from ThyssenKrupp? Well, I'm working to have all 19. Yes, but first of all, I would like to reiterate that Ceará is a great granary for green hydrogen to the world. We have natural conditions for that in your state. So many big companies are seeking to develop projects here. I'm sure they are having commercial proposals from us and from our competitors, and so we've been talking to several companies, but I understand the projects are not in the stage of defining their technology. So we are trying to persuade them to use ours. I think I can complement. So Hytron is one of the companies that signed the MOU. So in this one, I can guarantee at least one electrolyzer from Hytron. So we have a question here from WhatsApp. What would you recommend for our state to use its potentials to replicate what it's been doing, it's been done at Unicamp, University of Campinas? And so Hytron is a spin-off of the Unicamp Hydrogen Lab. So what would you say to the local universities to feature successful cases like this? So I would say in one statement: believe yourselves, believe your skills.
Na competência. Uma vez eu vi uma palestra, eu não lembro o nome do palestrante, ele falou que ele fez curso,
to make a long story short, so I watched the conference about Harvard students, because Harvard was great because Harvard is great because the students from Harvard, they believe strongly they are great. So we need to believe ourselves. We can overcome all the barriers.
Dá para superar os obstáculos, né? Que são vários.
So we have a background in Ceará, and we know that we can't give up in the first difficulties, and we have great umbrellas of us. For example, social justice. We have social and environmental goals. And when I was a student, a master student, I used to say to my partners, someday we will be global. It seemed years
E
ago
agora
that
já é.
was
Então,
seemed to be impossible, but
a
we are
evolução
here.
é muito mais do que isso.
And
O resto
besides believing in
é ter boas
yourselves,
ideias,
you
é ter
need
os
to have
professores do lado, é ter
infrastructure, good
infraestrutura,
professors.
é lutar
You need
contra
to
o futuro que
struggle
você
for
tem,
good
é ter bons
projects,
projetos, como
for
o próprio
good
Júnior falou
education, for
ontem,
good
né? Os
infrastructure.
recursos para os bons
I think
projetos
that's it.
existem.
Thank you, Danielle.
Obrigada, Daniel.
We have
Realmente,
another
esse é um exemplo.
interesting question just to
Teve
finish.
uma outra pergunta interessante que
It's about
só
water.
para terminar, que é sobre a água.
I don't know
Eu
if
acho que é
Marina
um
is
tópico
online for the
importante. Não sei se a
Q&A.
Marina
Yes,
está
she is.
online para perguntas e respostas ou
So
não.
Marina,
Ela está.
we have a question to
Marina,
you
tudo bem?
about water usage,
Tem uma
about the
pergunta
water
aqui
quality
sobre o uso da água, né? Qual a
demanded
qualidade
in
da
the
água
electrolyzers
exigida
and
nos
what is the consumption
eletrodizadores
of
e qual
water?
o consumo da
So
água
how
por quilograma de
much water
hidrogênio
for
produzido?
hydrogen produced? Well, the electrolysis process, the water needs to be demineralized, but we can add up water treatment plant together with the hydrogen plant. So I would say that we need to assess project by project, so there's no absolute restriction. If the water quality is too poor, the water treatment can be cost imperative, but the consumption is more or less 10 liters of water per kilogram of hydrogen, including the water consumed for the cooling systems, not only water as raw matter. Thank you, Marina. If you want to state your final
Obrigada,
remarks,
Marina. Se você
please.
quiser fazer suas considerações
Por
finais,
nada, eu gostaria de
Pode
Well, I
agradecer
would like
então
to
pelo
thank you
convite
for
para
the kind
participar e
invitation
parabenizar pela
and
organização do
congratulate
evento,
the event
pelo convite para
organization
participar e parabenizar pela
and for
organização do
all
evento
your work
e por todo esse
leveraging
trabalho que
green
vocês têm feito
economy
muito bem de
in Brazil.
impulsionar, né,
And we
a
hope that
economia
in
do
some
hidrogênio verde
years
aqui no Brasil
we have
e a
lots
gente
of
espera,
projects,
dentro de alguns anos,
being
ver muitos
developed,
projetos saindo do
leaving
papel aí no
the
Porto do Sul
sketch
também.
to reality.
Obrigada. Mr. Kamar, would you like to make some final considerations?
I don't know if Mr. Kamar is online. Well,
não sei se você quer
but
colocar alguma
Mr.
coisa mais
Luis,
sobre a questão
you
da
want to
água,
comment
que é muito
something
importante
about
aqui para o
water?
Estado.
Well, I think it's a
Não,
very
eu acho que
valid
é uma preocupação
concern.
super válida, né?
We
Não
can't
adianta querer fazer hidrogênio verde
only
e
simply do green hydrogen
usando uma água aí
and
que
using some
vai
water
fazer falta para outros
irresponsibly,
usos para a população.
the
Mas
water
eu acho
that
que,
will
independente da tecnologia das empresas,
would
há soluções para isso, né?
make
Eu acho que
population
qualquer
suffer
tecnologia é possível.
from shortage. Well,
Por
but we
exemplo,
can
da água do
use
mar,
seawater, for
dessalinizar,
example,
pré-tratar
desalinize it and treat
não
it,
comprometer,
and
vamos chamar
do
assim, a
not
disponibilidade de água doce potável na
compromise
região, né? Sim, mas sem
the
dúvida
supply of potable water.
completamente super válido,
I
né?
think
Não-
so. You cannot see things
você vê
only
só de
by
lado
one side.
e
It's not worth it to
comprometer a
use green
disponibilidade de
hydrogen
água.
and to
Essa é uma preocupação
compromise,
que o Estado
jeopardize the
já
water
está
availability
trabalhando,
for the
né?
population. So
Ele,
yes,
existe
we
essa
have this
tensão da
concern
Companhia de Águas de
with the
Fortaleza
local players,
de fornecer
for
água
local
tratada, água de
utility
reuso para as
companies
empresas que vão produzir hidrogênio verde no PCM.
to
E existe essa
provide water
possibilidade
to
também da
PSAM,
água
and we have this
desalinizada.
possibility
Luiz, você
to
quer fazer suas
provide seawater,
considerações
treated
finais?
seawater.
Não,
And
somente
your
para
final
parabenizar
remarks. Well,
pela
thank you for your
atenção.
attention. It's
É uma
been
grande
a
satisfação estar
pleasure
aqui
to
com
be here
vocês,
together with
estar junto
our
aí de novas
competitors,
empresas, da
great
Hydro, da
competitors.
Siemens.
Thank you, Monica.
Muito obrigado, Mônica.
This event
Eu
wouldn't
acho que esse evento
be
não
the same
seria
without you.
esse sucesso
Well,
sem
thank
vocês.
you.
Muito obrigado.
Thank you.
Obrigada a todos. Eu queria
I
fazer
would
agora desafio
pose a
rapidinho,
challenge to you that
que
is
eu
extremely
considero de extrema
important for the
importância
supply
a
chain
cadeia de
to
suprimentos,
attract
né?
companies,
Atrair empresas que fabricam
manufacturers of
equipamentos e
components,
componentes, né?
valves,
Válvulas,
pipes,
tubulações,
service providers in
empresas de
general, so
prestação de
deployment
serviços
and
para
installation
instalação,
service providers. So the
enfim,
supply
essa
chain,
cadeia de suprimentos
we need to attract
atraídas para o
companies
PCM e
to
para o
complete the
Estado do
supply
Ceará,
chain, and this
ela
attraction will
vai
generate each
gerar
day more
cada vez mais
job
empregos,
positions.
né?
So
Então não são
not
só
only
as
the
plantas
hydrogen,
de produção de
green
hidrogênio
hydrogen
verde, mas é toda
plants,
essa
it's not
cadeia. Então
only about
eu
green
convido
hydrogen
desde já
plants.
essas empresas,
It's about
né,
a
que quando
comprehensive
pensarem
supply chain. So I invite you
em planos de
to think
expansão e
about
abrir
when
novas
you think
plantas,
on opening new
que
plants.
pensem
So
no
think about
Ceará, que
Ceará,
pensem
think
no
about
PCM,
the exportation processing zone. Think about the Pecém complex, Pecém port complex. Think about European exportations or exportations to Europe. Your question, Alana. Alana, the indigenous and traditional communities are very important. So, and the green hydrogen plants are clean plants. It's important to say so. With no, they release no toxic waste, for example. The green hydrogen production is clean, but I think involving shore communities and the communities in the surroundings of these plants, I think it's very important. I think these work shall be done. It makes part of this green hydrogen hub implementation. We need to sit together, and I think it's a proposition. We have this proposition for the same port complex to start this dialogue from now, immediately. We have several ways to engage communities, not only in the plants that are being installed, but also in the production from plastic residues, for example. So in the residue, in the waste collection, in order to generate income for these communities, selling the waste material collected to the plants. I think we will take it very seriously, and thank you for your considerations. Thank you, Monica. Thank you. Thank to our fellow panelists, Luis and Danielle in person, and Mr. Kamar.